Hello, this is Professor Parker. Welcome to All This Math. And today, we're going to do some multiplication. Now, there are many different ways that we can multiply. And today we have two examples. We have 25 times 32, and we have 47 times 23. Today we're going to do a very not well known, as it should be, method of multiplication that we call Kemetic multiplication. Kemetic from the word Kemet, which is the ancient name for the country that we know of today as Egypt. All right, so some places might call this, or some people or some entities might call this ancient Egyptian multiplication. But I tend to call it Kemetic multiplication because I know about the name Kemet. All right. Now, how do we do this? This is how we do this. We have our two factors, 25 and 32, and we want to find what the product is. What is 25 times 32? What does that equal? Right? If I have 25 of something, and then I multiply it by 32, how many will I have altogether? First thing you can do is you want to draw like a table, like a T-chart almost. Just like that. Right? So we have 25 and we have 32. Now, in the first column, you want to write a 1 underneath of the 25. And in this second column, underneath of 32, you want to write 32 over again. Now, basically what we're doing with this method of Kemetic multiplication is we just double. We just keep doubling and doubling and doubling and doubling. But we do stop at a certain point, but we basically just double. So in the left side column, we're going to double this 1. It's going to become a 2. Correspondingly, in the right side column, we're going to double this 32. It's going to become 64. So we just double. 1 doubles and becomes 2. 2 doubles and becomes 4. Then 64 doubles and becomes 128. Now, in case you're a little worried about how am I supposed to know that? 64 times 2, and this is a good way to train yourself with mental math. 64 times 2 can be broken down in terms of the distributive property. So you could say 64 times 2, you could think of that as 60 from here times 2 plus 4 times 2. 60 times 2 gives you 120. 4 times 2 gives you 8. You add those two together, 120 plus 8, and you have 128. All right? So that corresponds to the 4, right? Then I double the 4, and I get 8. So then I double 128. That's going to give me 256, because 100 times 2 is 200, 20 times 2 is 40, 8 times 2 is 16. So 200 plus 40 plus 16 is 256. Then I double the 8, and I get the 16. Now, you might be wondering, when am I supposed to stop doubling? Do I just keep doubling forever? No, you don't keep doubling forever. You will eventually stop. And actually, we're going to stop doubling at 16. And why is that? Because you don't want the lowest number written, or the biggest number written rather, but just in the lowest position. You don't want the biggest number written here to exceed this number right here. And what would happen if I double 16? I would get 32. And 32 exceeds 25. We don't want that. So that tells us that we stop at 16. So then 256 doubles and becomes 512. 200 times 2 is 400. 50 times 2 is 100. 6 times 2 is 12. So 400 plus 100 plus 12 is 512. Now, next part. What we do is you look in this column right here, and you look for numbers, or these numbers that will add up to 25. So it's like a pattern you're looking for. So I know 25 is kind of big, so I'm going to take the biggest number out of this group. I know 16 is going to be one of the numbers used to add up to 25. And then I say, okay, what if I add 8 to 16? That's going to give me 24. And then how many more do I need to add to get 25? Just 1. So 16, 8, and 1 will add up to 25. 16, 8, and 1. Those three numbers add up to 25. So that means that the numbers that correspond to them, 32, 256, 512, they will add up and give us our product of 25 times 32. So our next step is just to add these three numbers up, 32, 256, and 512. So I can do this. I can do 32, and when we're doing addition or subtraction, make sure you're lining your numbers up according to place value. Ones over ones, tens over tens, hundreds over hundreds, thousands over thousands, 10,000s over 10,000s, and so on and so forth. So I got 32, 256, I write 6, 5, and 2. So I line up my ones and my ones, my tens and my tens, hundreds, and then I got 512. So 2 plus 6 is 8, 8 plus 2 is 10. Write 0, carry the 1. 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 1 is 10. 0, carry the 1. 1 plus 2 is 3, 3 plus 5 is 8. The answer is 800. And you can check your work. Use a calculator, do 25 times 32. Or if you trust some other methods that you might have learned, like the standard multiplication algorithm, where you have 25 multiplied by 32 vertically, you can check it using that method and see if you get 800. Matter of fact, I'll do that right now. 2 times 5 is 10. That's 0, carry the 1. 2 times 2 is 4, plus 1 is 5. 3 times 5 is 15. Make sure you go in one space, right? 3 times 5 is 15. Write the 5, carry the 1. I already got a 1 there, so I could just use that 1. 3 times 2 is 6. 6 plus 1 is 7. 0 plus nothing is 0. 5 plus 5 is 10. Write the 0, carry the 1. 1 plus 7 is 8. You get 800 that way too. But this is another way to do it, which also helps us to develop our skills at doubling numbers. All right? Now, second example. Over here, 47 times 23. 47 times 23. What we want to do is draw our T-chart, and then we write a 1. And then we copy this number over. So we got 1 and 23. And we're just going to play like a doubling game. We just double each of these numbers. Boom, 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 boom. So you double 1 and you get 2. You double 23, you get 46. Because 20 times 2 is 40. 3 times 2 is 6. 40 plus 6 is 46. That's all we doing. Double the 2, you get 4. Double the 46, you get 92. Because 40 times 2 is 80. 6 times 2 is 12. 80 plus 12, together, 92. Double the 4, you get 8. Double the 92, you get 184. Now you might be worried that 47, you might be saying, whoa, hold up. That 47 is a little large. So I'm going to be writing numbers for a long time. You really won't. Because once numbers start doubling, what's happening is the numbers are growing exponentially. And they're going to start to grow real quickly. All right? So you double the 8, you get 16. So we're about to be to 32 already. And we're going to stop at 32. Because if I go past 32, I'm going to be at 64. And 64 exceeds 47. So I'm going to stop at 32. And that's just one more number anyway. But 184 times 2, 100 times 2 is 200. 80 times 2 is 160. That's 360. 4 times 2 is 8. So that's 368. Right? Let me extend that some. Double 16, you get 32. Double 368, you get 600. Double the 300, you get 600. Double the 60, you get 120. So that's 720. Double the 8, you get 16. 720 plus 16 is 736. 600, 120, and 16. We stop at 32. Again, why do we stop at 32? We stop at 32 because if we go past 32, if we double 32, we get 64. 64 is bigger than 47. So we stop at 32. So now we're looking for numbers that add up to 47. Numbers from this column. This column that add up to 47. So I'm always using my biggest number. My biggest number is 32. So 32 plus what will give me 47? If I add 16, I'm over 47. I'm at 48. Can't do that, right? So I can't use 16. So 16 is no good. What about 8? If I add 8, now I got 40. 32 plus 8 is 40. Now I need 7 more. And look what happened. 40 plus 4 is 44. 44 plus 2 is 46. And 46 plus 1 is 47. So I basically got to add up all these numbers, right? So I got to add up 23, 46, 92, 184, and 736. I could do that right here. 3 plus 6 is 9. 9 plus 2 is 11. 11 plus 4 is 15. 15 plus 6 is 21. So I write a 1, and I carry the 2. 2 plus 2 is 4. 4 plus 4 is 8. 8 plus 9 is 17. 17 plus 8 is 25. 25 plus 3 is 28. Write the 8, carry the 2. Can't go up here. I need a 3-digit number. Put the 2 right there. 2 plus 1 is 3. 3 plus 7 is 10. 1081. And that, my friends, is Kemetic multiplication or ancient Egyptian multiplication. It's also kind of like why I wore a sweatshirt when I knew I was going to do this lesson. Because this I like to think of as Hatshepsut, who was an Egyptian pharaoh, a queen, actually, from a dynasty that I cannot remember, right? But understand that Egypt is part of Africa, despite what people like Mary Lefkowitz try to lie to us and convince us of. And they write books and get book deals and tell lies about the fact that countries like Egypt are not part of Africa, right? But we have plenty of scholars that have debunked that idea. We just have to read them. That's fine. But anyway, there's always a connection between history and mathematics. And mathematics, just like any subject or any discipline that we study, is very political. All right? And hopefully we can develop our mathematical skills for nation building. And this is just one of the skills that we can use. Kemetic multiplication, aka ancient Egyptian multiplication. Thank you for tuning in. I hope you learned something new. Please continue to send your problems to the All This Math DM, and your problem might end up on this board. Peace.